Welcome to this video on smart attendance system, which we embedded Monsters team has developed as a part of our GFC embedded course. This is Akram Ashraf, and I'm going to brief you on the aim of the project. This smart attendance system aims at automating the attendance procedure so that it becomes easier, faster, and error-free. This smart attendance system limits human interference and thus eliminates any human errors. Now, please allow me to introduce my colleagues who will walk you through how each component works. Let's start with David Mina and Yusam Joseph, who will tell us more about the RFID.
David Mina, please let me guide you through how we use the RFID reader. First of all, we decided to make use of the serial peripheral interface available in the Arduino Mega. In terms of hardware connections, the RFID has 8 pins. The 3.3 volt pin is connected to the Arduino's 3.3 volt. The ground pin is connected to the breadboard common ground. The reset pin is connected to digital pin 8. Moreover, the master in slave out pin and the master out slave in pin are connected to the digital pins 50 and 51 respectively. The SCK pin, which stands for serial clock, is connected to digital pin 52. And finally, the SDA pin, which stands for serial data, is connected to digital pin 9, which is one of the PWM pins. This was all about the hardware connections. Now it's time for my colleague Yusam Joseph, who will proceed with the logic of how this sensor works.
Hello guys, this is Yusam Joseph. Let's dig into details regarding the implementation of the logic of our system. In this project, we initialized an array of strings called IDs, which stores the IDs of students allowed to enter the classroom in addition to the instructor's ID. These are all read from the RFID tag or card. The next step is that we read the ID of the tag or the card placed above the RFID reader and compare this ID against the stored ID. If it matches the TA's ID, then the TA is welcomed, session starts, and start time is recorded. If it matches a registered student's ID, then he is allowed to enter the classroom, and the time he enters the classroom is recorded, if the session has already started. Otherwise, access to the classroom is denied. If a student already inside the classroom showed his ID, then he is allowed to exit the classroom. With the help of the servo motor, the classroom door is controlled, enabling instructors or students to enter and exit the classroom upon showing their IDs. And a few seconds after anyone enters or leaves, the door closes again automatically. In case of a fire, which is detected using a smoke sensor, the door opens without the need of IDs to enable whoever inside the classroom to leave instantly. My colleague Akram Ashraf will elaborate more about this part of the servo motor. Now, my colleague David Mina will resume with the rest of the logic involved in our system.
Welcome again. Let's proceed with our implementation. When an instructor inside the classroom shows his ID, the session ends and the attendance of every student is calculated using the formula student duration inside classroom divided by session duration. If this yields a number that's greater than or equal to 0.75, meaning that the student spends 75% or above of the session inside the classroom, he is recorded as attendant and otherwise absent. Our approach is considered to be user-friendly as it took into consideration that a student, for example, may exit the classroom to go to the bathroom and returns back again. So when he comes back, the time he spends inside the classroom will be added to the time already spent before leaving. And finally, at the end of each session, the attendance records are written to a text file. Now it's time for my colleague Amgad Ashraf to tell us more about the smoke sensor.
It's Amgad Ashraf. I will guide you through the MQ2 smoke sensor. Regarding the hardware connections, this sensor has 3 pins. The 5 volt pin is connected to the Arduino's 5 volt. The ground pin is connected to our common ground in the breadboard. And finally, the analog pin is connected to the analog pin A0 of the Arduino Mega. For the logic part, the functionality of this sensor is to detect smoke simply by continuously reading the smoke level that exists in the atmosphere. If this level goes beyond a certain level, which corresponds to almost clean air, the sensor outputs a higher voltage. That was all about the smoke sensor. Now my colleague Akram Ashraf will tell us more about the servo motor.
For the servo motor has 3 pins. One pin is connected to the 5 volts of the Arduino board. one pin is connected to the ground of the Arduino, and one pin is connected to the digital pin 7. As in the part of the code, the motor has an attached method that we attach pin 7 to the motor, and has a method called .write that takes an angle. If you want to open the door, we make the angle 90, so if the door opens. If you want to close the door, we make the angle 0, so it closes the door. My colleague Shadi will proceed with the part concerning the LCD.
Hello guys, it's Shadi Sharif. I will guide you through the LCD display. In terms of hardware, the LCD data output pins D4, D5, D6 and D7 are attached to the Arduino Mega pins 10, 11, 12 and 13 respectively. This is in addition to the RS and EN pins attached to the pins 31 and 30 respectively. For the software part, an instance of the Liquid Crystal library is created and a begin method is executed to set up the LCD's numbers of columns to 16 and number of rows to 2. The usage of the LCD is to display a message on the screen with any event happening. For example, it displays a message when the instructor and each student enter or leave the classroom. It also indicates the start and the end of the session, and finally shows whether each student is recorded as attended or absent after each session. Moreover, the number of students currently in class is always displayed. Thank you, and now I'll be leaving you with testing of the project.
Now it's time for a demo. Let's have fun together. This is the instructor's ID. Welcome instructor is displayed and session starts. The number of students currently in class is 0. We will enter as the first student. The door opens, then closes after he enters, and the number is now 1. We will enter another student. It's now 2. The third student. This is an invalid ID which tries to access the classroom. It should not be allowed to enter. Access is denied. And finally, we have the fourth student. Now, a student who was entered in class wishes to exit. It says bye, and the number is decremented. Another student exits. The door opens also and closes. Now 2 students are in class. Shadi also will exit. Now only 1 student is in class. Okay, it seems the session will end now. Session ends. The door is open. This is the attendance. David attended because he spent more than 75% of the class duration in class, and all the others should not be recorded as attended. Now we will test the smoke sensor. Okay, the door opens and fire is written on the LCD. This indicates that there is a fire and everyone needs to leave instantly. This was our project. Hope you like it. Thank you for your precious time and undivided attention.